turn to page 3 of your iPod. We're going to cover Unit 6, Lesson 1, Systems of Equations, Types of Solutions. So today we're going to talk about the different types of solutions there are. So in this one, I need you to know that these lines are parallel, and the type of solution that you're dealing with is a no solution. And the reason why there's no solution is because they have no points in common. So here you have parallel lines, they never intersect. That's a no solution. I need you to notice, if you're looking at the equation, your slopes are the same. So here, this slope is 2/3, this is 2/3. So here in a no solution, your slopes are the same. Now your slopes will also be different. All right. So this is no solution. The next one. Okay, these are two intersecting lines. So they intersect. They have one solution because they only intersect at one point, and that point is an ordered pair where x goes first and then the y. So here you have one solution and they only have one point in common. Here I need you to know that the slopes are different. And on the y-intercepts, it can be the same or different. So this one can be both. But I need you to know specifically that your slopes will be different. You can have the same y-intercept, but you won't have the same slope. Okay, last one. There is actually a second line on here. I know you can't tell, but there is a second line. So I'm putting two arrows there so that you can see that there are two different lines. So here you have a same line, so there's two lines that are the same, and what I need you to know is that these are called infinitely many solutions. And here they have all points in common. So every single point that you can think of, they have in common. Okay, so let's, from yesterday we talked about solving for y. So if you look here, this is already solved for y. On this one, we're going to have to solve for y. So I'm going to move the x, change its sign. So there's a 1 in front, so I don't have to divide by the number in front of the y. So I have y equals, and remember we like x going first. So if you can tell now, this says y equals x minus 1, and so does this one. So here on this one, I need you to know that not only are the lines are the same, the equations are the same too. So here your slopes are the same, and so are your y-intercepts. So identical lines, identical equations. And this is infinitely many solutions. Your EOC test could say all real numbers, but I just need you to know that every single point they have in common. Okay, so let's go to page 4. Alright, so this is page 4, and we are going to talk about whether or not points are part of the solution. So if you look, it's asking us to tell whether or not these 4 points on the side are a solution to the system. So what I need you to know is that basically what we're doing is we're plugging in the x and the y where they belong. So just as a little friendly tip, you don't have to do this, but I'm going to do this just so that you can see. We're going to plug in these numbers where all the x's are, and we're going to plug in the green numbers where the y's are. Let me show you that I highlighted those. So here what we're saying is 5x, which is 0, plus y, which is 4, does that equal 4? Well, if I put that in the calculator, that gives me 4. So does 4 equal 4? This is a true statement. Okay, so in order for it to be a solution, both of these statements have to be true. So now I have to test this one. So my x was 0 and my y was 4. So 0 minus 4, if I put that in the calculator, it gives me negative 4. So is negative 4 equal to 2? This is not a true statement. So that means that this is not a solution. So is this point a solution to the system? No. So they both have to be true in order for it to be a solution. So let's go ahead and check this other one. Okay, so I'm going to start it off like I did the other one, but this time I'm going to write it in. Oh, that shouldn't be a 4, that should be a parentheses. So both those go there. When I put this in the calculator, I get 6. Does 6 equal 4? No, it does not. Since it doesn't, I can tell you already, I don't have to do this part because this means this is already not a solution. So if it's not true for one, there's no point in doing it for the other. Okay, so let's look at the third one. So 5x plus y equals 4. So I'm putting 1 here, negative 1 here. I put this in the calculator and it gives me 4. So does 4 equal 4? Yes, it does. So I need to go check the other equation. So minus y equals 2. So 1 minus negative 1. So I put this part in the calculator, it gives me 2. Does 2 equal 2? Yes, it does. So that means, since both of these are true, that means this is a solution. Alright, last one. So 5 times x plus y, which is negative 2, equals 4. So that's, once I put that in the calculator, it gives me negative 2. Does negative 2 equal 4? No, it does not. I can stop. That's a no. So what is our solution to this problem? Our solution would be 1 comma negative 1. That is our solution. So again, you're looking for where it's true for both equations.